Hey there, welcome to this exciting session on Kubernetes. So if you're new to this channel or if you're watching my videos for the first time, I would highly recommend that you check out the earlier videos because this video is a part of a series. And the link to the series you will find in the description of this particular video. So talking about what we are going to cover, yes, we are going to talk about Kubernetes. We are going to talk about what Kubernetes is, why you should make use of it. We are going to talk about concepts like pods, services, and we will even set up our own Minikube dashboard onto our system. We are also going to understand what ReplicaSets and deployments are so that your applications are not only up, but they are also scalable and manageable. So if you're not aware of any of these terms like pods, ReplicaSets and all, don't worry, we'll cover each one of them in this particular session. So this is going to be a complete hands-on session where we will be actually doing things in a hands-on way practically. Now, if you have been watching my videos and if you haven't liked or subscribed yet, I would highly recommend doing so. Because every subscriber or every subscription that I get on my channel motivates me to bring in more such amazing content for you all. The support and love that I get from my viewers impacts my ability to bring in more such amazing free content for you all. So I would highly recommend that you hit the subscribe button, like this particular video and turn on the bell notifications. Also feel free to leave a comment to let me know what kind of videos I should bring for you all. Now, without a further ado, let's jump right into the session. Welcome back. So let us start talking about Kubernetes and let us understand what is Kubernetes. So first, I would want you all to raise your hand if you have ever been scared by the sheer number of containers that you had to manage in Docker. So this is a problem and one of the major problems that developers always have. So if you're working on a real world project, there are n number of containers that you will have to manage with the help of Docker and Docker Compose. Now, to solve this problem, this is where Kubernetes comes into picture. So let us take a step back into history and understand how Kubernetes came into picture or how Kubernetes came into existence. So the story of Kubernetes begins with Google. Yes, that's right, Google. So imagine the amount of load Google has to manage with billions of searches happening every day. And not to mention YouTube, Gmail and all its other services are so popular that they have a lot of load. Now to manage this, Google built a system named Borg. Okay. So the system was internally known as Borg and it was so useful that they decided to create an open source version of it. And this project initiated around 2014 and this is what now is known as Kubernetes, or it is also sometimes referred as k8s. But what exactly does Kubernetes do? So simply put, it is an open source platform that automates Linux container operations. So it eliminates many manual processes involved in deploying, scaling containerized applications. Okay. And in other words, you can cluster a group of hosts running Linux containers and Kubernetes can help you manage those clusters easily and effectively. So Kubernetes is essentially a platform designed to completely manage the lifecycle of containerized applications using methods that provide predictability, scalability, and high availability. So consider a scenario wherein you are running multiple containers and you need these services to talk to each other. You also need to restart them automatically if they fail. And you need to have X number of instances always up and running for a particular service. So this can be addressed by Kubernetes. So Kubernetes provides you with a framework that enables you to run distributed systems resiliently. And it takes care of scaling, failover of your applications. It provides you with deployment patterns and more. So you define how your application should run and the ways they should be able to interact with each other or the outside world. And once you define this, Kubernetes will take care of this. Okay. Now, Kubernetes did not become popular overnight. Its success is attributed to the fact that it addresses a critical issue as to how to manage and orchestrate containers at scale. And not just that, Kubernetes also supports multiple container runtime environments, including Docker and so on. So you can run containers on any operating system, on any cloud, and in any region. Okay. So this is why Kubernetes is very popular. So Kubernetes, like I said, is essentially designed to manage the lifecycle of containerized applications. So that's Kubernetes for you. Hey there, welcome back. So let us start talking about the benefits of Kubernetes. So the number one benefit that we have is service discovery and load balancing. So Kubernetes can automatically expose your containerized services to the internet or any other services in the same cluster using a DNS name or an IP address. Now, if there is high traffic, Kubernetes can distribute network traffic to provide load balancing and ensure that your deployment is stable. For example, if you are building a busy e-commerce website during a big sale, and as the traffic increases, Kubernetes has the ability to evenly distribute the load amongst different instances of the site. And this ensures that the site remains responsive and does not crash under heavy load. So this is the number one benefit of Kubernetes. Then you have automated rollbacks and rollouts. So when you describe the desired state of your deployed container, Kubernetes can change the actual state to the desired state at a controlled rate. So if there is a mistake, Kubernetes will roll back the change for you without any downtime. For example, if you're deploying a new version of your application and you discover a critical bug in the update, so Kubernetes can quickly roll back to the previous version, minimizing downtime and the impact that it will have on the users. The next benefit we have is horizontal scaling. So Kubernetes can scale up your application and it can even scale down with a simple command. And you can even do this with the help of a UI or automatically based on CPU usage and other application specific metrics. So in case of an unexpected surge of users in your application, Kubernetes can automatically spawn more instances of your application to handle the increased load. So this is about horizontal scaling. Then we have self-healing. So Kubernetes constantly monitors the health of your nodes and containers. It does not replaces the container that fail. So it will restart the container that don't respond to health check and doesn't advertise them to clients until they are ready to serve. So for example, if a container in your application crashes due to an unexpected error, Kubernetes will automatically restart without needing manual intervention. And this will minimize the potential downtime or degradation in the service. Then the next benefit you will have is secret and configuration management. Now Kubernetes lets you store and manage sensitive information like passwords, OAuth token, and SSH keys. So you can deploy and update secrets and application configuration without rebuilding your container images and without exposing any sensitive data in your stack configuration. For example, instead of hard-coding sensitive information like database credential into your application, you can provide them securely using Kubernetes secrets. And this will improve the overall security of your application. So these are the benefits as to why Kubernetes should be used and how it makes the life of developers easy. So that's about the benefits of Kubernetes. So let us begin talking about the Kubernetes architecture. So Kubernetes architecture consists of control plane and worker nodes. So what are worker nodes? So worker nodes are machines that run your application. Now each worker node contains a kubelet, as you can see over here, and kube proxy. Now what is a kubelet? So kubelet is an agent for managing the node and the communication with the Kubernetes control plane over here. So all the communication between control plane and the worker node is done by kubelet. Now worker node also has something called as pods. Now what are pods? So pod is nothing but the smallest and simplest unit in Kubernetes object model that you can create and deploy. So pod represents a running process on your cluster. Okay. Now what do you mean by cluster? So cluster is nothing but a set of nodes that can be used to run containerized applications. Okay. And they have pods. Now pods contains of multiple containers, as you can see in the diagram. And there is a container runtime that is provided to them for execution purpose. So this is about worker node and what all it has. Now Kubernetes architecture includes worker node. Now worker node runs containerized applications, and another component is the control plane, which manages the state of the cluster. Now control plane has several components like API server, it has controller manager, scheduler, and etcd. Okay. So API server is nothing but the interface between the control plane and the rest of the cluster. So these are all clusters that you have, and API server is the communication medium between the control plane and the rest of the cluster. So API server, you can say, acts as a front end for Kubernetes and its main management point of the entire Kubernetes system. Okay. Now this is about API server. What is etcd? So etcd is a distributed key value store that holds the cluster's persistent state. So there will be scenarios wherein you might want to hold some data that persists. So that is where etcd come into picture, and it stores the configuration information which can be used by each of the nodes in the cluster. Okay, and this is critical part of Kubernetes. It allows Kubernetes to store the state of the cluster. Then you have scheduler. So scheduler places the pods into worker nodes. So here you have pods in the worker nodes, and this is done by scheduler, and this is done based on resource availability. So scheduler is responsible for distributing work or containers across multiple nodes. So it tracks the utilization and the workload of the cluster nodes and makes sure that it allocates them appropriately. And then you have controller manager that runs controllers to manage the state of the cluster. Okay, so this is about the Kubernetes architecture. So you can think of this like you will have multiple worker nodes that will have multiple pods running different containers. Okay, then you also have container runtime, and this is the runtime software that is responsible for running containers. And then you have kubelet, and kubelet, like I mentioned, it's an agent that runs on each node in the cluster, and it ensures that containers are running in the pod, and it acts as an interface with the control plane over here. So this is about the architecture of Kubernetes. Hey there, welcome back. So let us start setting up our environment to work with Kubernetes. So the number one thing that we will need to get started is Minikube. Now what is Minikube? So Minikube is nothing but a tool that makes it easy for us to run Kubernetes locally. And like we know, Kubernetes is a powerful container orchestrator system that manages deployment, scaling, and operation of containers in our system. So we will need to have a way to run Kubernetes onto our system, and Minikube is that way for us. So I'm going to head over to Google and I'm going to search for Minikube Kubernetes. So here you will see the first link, which is of the Kubernetes website. So we won't go there, but instead we will go to Minikube official website here. Okay, and you will be taken to this web page over here. So you can see Minikube is local Kubernetes, which means it enables you to set up Kubernetes onto your local system. Now, here are some reasons why you might need Minikube. So Minikube is used for local development and testing. Okay, so if you are running Kubernetes, and if you want to test your application locally with Kubernetes, then you can make use of Minikube. And Minikube will mimic the real Kubernetes cluster and enable you to work with it. It is also important to use Minikube for learning and experimentation. Okay, since you are not working on production, on development environment, you can use it for learning and production. So this is why you can use Minikube. Now, should you use Minikube in production? Absolutely not. So Minikube is intended for local development and testing purpose. And if you are deploying your application to production, you will have a full-scale Kubernetes cluster provided by the cloud platform or on-premises infrastructure. So what I mean by this is, if you are deploying your application to Amazon, you have the Amazon Kubernetes. Okay, so if you search over here, Amazon Kubernetes. So it's called Managed Kubernetes Service, which is EKS. And then same for Google, you have their Managed Kubernetes Service. So you can use that. You don't need Minikube for that. So let's get ahead with the installation process. So if you scroll down over here, just make a note of all these requirements. Okay, so you need 2 CPUs or more, 2 gigs of free memory, 20 gigs of free space, internet connection, and a virtual machine manager such as Docker or any of these. Okay, so we have Docker installed, and you can choose which operating system you are on. So I'm on Windows stable, and you can choose the installer type. So you can choose exe, Windows Package Manager, or Chocolatey. If you're on Mac, you can choose your architecture. Then you can go for binary download, or you can install using Homebrew. Okay, so you just need to execute this command if you have Homebrew installed, or if you don't have, you can go for this command, which is binary installation. And similar process we have for Linux. So I have Windows, and I'll select this and I'll download the latest release over here. So once you have downloaded the exe, you can double click on this. You can say yes, and you can go through the process of installation. It is a simple process that you can go through. I'll say next, and it will install this for me. So the installation is complete. Okay, now what you need to do is we need to start using Minikube. So for that, I'll head over to PowerShell. Okay, and let us write a command over here. So I'll say clear, and I'll say Minikube. Let us see if this works. Okay, so Minikube is all right. So this command worked for me. And what I did is I just restarted my terminal. So terminal was open even before installing the Minikube. So after installing Minikube, I have to restart the terminal. So I restarted and I typed in Minikube, and I can see that it's being recognized. Now I can say minikube.start or minikube start, and this is going to start the local instance of Minikube. So you can see it is downloading Kubernetes over here. It is starting control pane node. Okay, and it is using Docker desktop driver with root privileges, which is fine. Now when I said Minikube start, I saw some processing and I got this error. So it says that failed to start because virtualization is disabled. Okay, so it says this computer does not have VT-X enabled. Okay, and you need to enable the virtualization support on your computer. And for this, you need to restart your computer, enter the BIOS, and enable virtualization. But let's say I don't want to do that. So let me try running Minikube with a different driver. So I'll say Minikube start, and here you have a suggestion, driver equal to Docker. So I'll just copy this and I'll paste it over here. Okay, so hyphen driver equal to Docker, and I'll press enter. Okay, so I'm getting an error over here. So it says existing Minikube cluster was created using VirtualBox driver. So you need to delete that first. Okay, so you need to say Minikube delete. Okay, so it will delete this, and now you can start using Docker. So let us see if this also gives us the same issue of virtualization. So since I have Docker already installed and configured, I can leverage that to start Minikube. Now you can see this took some time, like there was some processing is what I saw, and this is complete now, and we did not get any error this time with Docker as a driver. Okay, so we just have to make sure that Docker is up and running. So this is done, and you can see the message kubectl is now configured to use Minikube cluster. So what is kubectl? So kubectl is a way using which you can interact with Minikube. So in order to see the status, you can say kubectl, and I can say cluster-info. So this will give me the information, and it says Kubernetes control plane is running over here and core DNS is running over here. So this tells us that kubectl or Minikube is completely set up on our system and it's up and running. Okay, so this way you can get this setup done. Okay, now there are different options when it comes to starting Minikube. So you can say Minikube start -- driver Docker. You can even use Hyperkit as driver. Okay, so if you wish to use that, you can use that as well. Okay, so this is about Minikube and setting up your environment on your Windows or Mac machine. Hey there, welcome back. So let us start talking about Minikube Dashboard. So Minikube offers a dashboard, which is a web-based user interface that you can use to observe the state of your Kubernetes cluster and even manage its resources. So while you can do everything via a command line with the help of kubectl command, you can even make use of dashboard, which gives you a more visual representation and an intuitive way to interact with your cluster. So how can you access the dashboard? So to access the dashboard, you need to say Minikube Dashboard. The moment you press enter, this will open up the dashboard in the browser. So you can see it is taking a little bit of time. It is saying enabling dashboard, and it says like there is some add-on that is needed, and you will see this open up. So this is nothing but the dashboard. Here, as you can see, that we don't have anything deployed yet, and neither there is any namespace. Okay, and you can see different options over here. So this is a visual representation of what you can do with Kubernetes. Okay, and this is inbuilt, like we have not created this, and this enables you to do things like monitoring, managing resources, accessing logs, access control, and it can also be a learning tool essentially. Okay, so yeah, this is about Kubernetes or Minikube Dashboard, I should say. Hey there, welcome to this class. So let us start talking about pods. So what is a pod in Kubernetes? So a pod is nothing but a basic building block in Kubernetes, and it represents the smallest deployable unit. You can think of it as a group of one or more containers and their shared resources, such as volumes, IP address, and network ports. Containers within a pod run on the same worker node and share the same life cycle. Now, pods are ephemeral and can be created, scheduled, and destroyed dynamically. So these are some of the characteristics of the pod. Now let us talk about what a pod is not. So pod is not a durable entity. So if a pod fails or is terminated, it cannot be restarted or resumed. Instead, a new pod will be created and it will be replaced. Pods are not designed for horizontal scaling on their own. So, scaling is typically achieved by creating multiple identical pods and distributing the workload amongst them using a high level construct like deployment or a replica set. So, you cannot horizontally scaled pod by itself. You need to do it with the help of deployment or a replica set. Now, there are some key considerations when you're working with pod. Pods should be designed to be stateless, like any state or data that needs to be preserved should be stored in external volumes or managed by high level abstractions like stateful sets. Pods communicate with each other within the same cluster using localhost. So containers within the pod can communicate with each other via inter-process communication mechanisms like shared memory. Pods are assigned a unique IP address within the cluster, which means that they can communicate with other pods or external services using that same IP. Let us talk about lifecycle and availability. So lifecycle and availability of pods are managed by Kubernetes. So it monitors the health of the pods and takes action like restarting or rescheduling pods whenever necessary. Now, pods can have associated labels and annotations which can be used for grouping, filtering, and selecting pods when we define deployments, services, or other Kubernetes resources. So, how can a pod be created? So, this is a sample code which is used to create a pod over here. Okay. Now, let's break it down. So, you can see at the top you have API version. Now this specifies the version of Kubernetes API that you are using to create this object. And pod is nothing but an object in Kubernetes. Then you specify the kind. So this specifies the type of Kubernetes resource that you are creating. And in this case, it's a pod. Then you specify the data type that uniquely identifies the pod. Okay. Then you have metadata, which is nothing but the data that is specified to uniquely identify the pod. Then you have things such as spec. Okay. Now, spec describes the desired state of the pod and what applications or services it should run. It includes the details about the containers, volumes, and other data. So if you take a look at this container tag over here, you will see it includes details like name, image, ports, and container port as well. So name is nginx over here, and this is the name of the container that will be running in the pod. And image, this is the image that we are using, and this is a Docker image that we are specifying over here. Then we have ports, where we are specifying the network ports that the container should expose. And container port 80 here in this case specifies that container should expose network traffic on port 80. What you can even do is you can add more containers to the pod. So here, this is the different version of the same file. Okay, you can see here I have one more container specified, and this container is now of Redis. Okay, so here I'm specifying the name and the image that this particular thing would use. All right, so let's get hands-on with this and let us create our first pod. So now to go hands-on, I'm here on my desktop and I have created a new folder called k8s. Okay, and I will be using a different IDE than IntelliJ for this purpose. And I am making use of Visual Studio Code, and I have even opened the folder k8s over here. Now, if you are not familiar with Visual Studio Code, or if you don't have it installed, I would recommend heading over to Google and searching for Visual Studio Code over here. And you can click on this particular link first. So it is an IDE which you can use, and it is free and open source. So you can download it for Windows, Mac, or Linux. So whichever operating system you are on, you can download it and you can open it. Okay. So after installation, what you need to do is you need to go to File, you need to say Open Folder, and you need to select the k8s folder that you have created on your system. And then it will open up something like this. Now here, what we need to do is we need to create a new file, and we will call this file as first-pod, and we'll specify this as YAML. Okay. So I have defined or I have created this particular file. So after creating this file, we need to add the code. So I have the code written over here in this particular notepad. So what I'm going to do is I'm going to simply copy paste this code here. So I have a code for a single container as well as for multi-container. So let us copy this and let us save this over here. Okay. So this is the code that I have added. Now we need to create this pod. Now how do you create the pod? So for that, we will head over to our terminal. Okay. Before heading over to terminal, just make sure that you have saved the file. Okay. So if you were seeing a dot over here like this, okay, you can see this round dot. It means that you have not saved the file. So you need to hit Ctrl S and it will change to cross this way. Now, in order to work with or in order to create the pod, we will head over to Windows PowerShell or any terminal that you have on your system. And you need to navigate to the directory k8s. Okay, so here I'm in this directory k8s. Okay, I'll clear this and I'll run the command. I'll say kubectl apply -f first-pod.yaml. Okay, and I'll hit enter. Now you will see the pod has been created. Now this command is used to create the pod, and -f is followed by the file name or the path to the file that contains the resource configuration. Okay, and we have the resource configuration defined over here. Now when you run kubectl apply f file name, Kubernetes reads the file, interprets the resource definitions, and applies them to the cluster. If resource already exists, it will update them to match the definitions in the file. And if they don't exist, it will create them. Now let us modify this pod that we have created. So here I'm going to open this notepad and I'm going to copy this second definition that I have over here. So I can paste this. Remember to save. And then if you go over here and if you say apply, you will see my pod is invalid. Okay. And pod updates may not add or remove containers. Now this suggests that you cannot modify the given pod. Now why is that so? So in Kubernetes, the specification of pod is immutable, meaning that pod once created, you cannot directly add or remove containers from it. And the reason for this is consistency. So Kubernetes ensures that pods are consistent and predictable as well. Okay. And atomicity is another reason wherein pods are treated as atomic units. Okay. And by allowing modification to pods container could introduce complexity in managing pods life cycle and also pods identity. So every pod has a unique IP address or hostname assigned, and modifying the containers within the pod could affect the pod's network. So now we have this pod created, and if we wish to have a new pod or a pod that has a different configuration, you need to add that as a new pod. Okay. So you have kubectl get pods. So if you run this command, you will get the list of all the pods that exist in your system. So right now we have one pod. Now what we will do is we will modify this pod and we will say this is my new pod and I'll hit save. So what we are doing is we are now, instead of updating the existing pod, we are now creating a new pod. So I'll say over here kubectl apply -f first-pod.yaml. And you will see this message here. And if you get the pods, you will see that the status is container creating. So you can say get pods -w. So -w will run this command in the watch mode and you will get live status updates. So as of now, the status update is not there because it's already changed to running. Okay, so to exit, you can say Control C or Command C on Mac. So this will update and this is known as a watch mode. Okay, so this way you can get your pods created and you can view them. So this is all about pods. Just remember one thing, that Kubernetes does not allow you to make changes to containers within a pod, and it is recommended to create new pods with the desired configuration and terminate the existing pod. Okay, so just make sure to keep this in mind. All right, so this is about pods and how they work. Hey there, welcome back. So let us start talking about service in Kubernetes. So what is a service? So service in Kubernetes is an abstraction that defines a logical set of pods and a policy by which to access them. And this is sometimes called as microservice. Now what I mean by this in simple terms is a service is nothing but a way using which you can access the pods. All right. So why do we need such a thing? So this is needed because pods in Kubernetes are ephemeral, which means that they can be created anytime and they can be destroyed, right? So you cannot rely on pods or pod IP to access them because IP is dynamic and it will change if a new pod is created and added to the cluster. So how would you access and make sure that you have a single access point to your pods or containers? So this is where service comes into picture. So with the help of service, you can have persistent connection to the pods it needs to access and regardless of changes in those pods. So this is irrespective of changes in the pods. So services enable you to help communicate with the pod. So now, given the ephemeral nature of pods, this greatly simplifies the network configuration and provides a simple way for us to access other pods, right? Now, the question is, how do you define a service? So here on my screen, you can see a simple YAML file, and this file specifies the application classification, the ports protocol, and the set of pods that can be targeted with the service. Okay, so here you can see we have specified the API version first, then the kind of the object this is. So it's a service kind, and this specifies the type of Kubernetes object or resource that you are creating. And then you have the name that you have given to this particular service. And this is comes under metadata, and metadata is the data that helps you uniquely identify the service. Like for example, its name. Then you have the spec, and this section specifies the desired state of the service. And this will include various properties like selector, ports. So selector, this field is a map of key value pairs, and a service will route the traffic across the set of pods that match the selector label. Okay. Then you have ports, and ports is the array that defines protocols and ports. Okay. So here you have TCP protocol, ports 8080, and target port is the port on the pod where your traffic is routed. Okay. It can be a port number or a name. If not specified, it defaults to the same as the port field. So this is the definition. So now let us head over to Visual Studio Code and let us start defining our service. So here I have this notepad wherein I have written the definition of a sample service. Now what I'm going to do is I'm going to copy this information and I'm going to create a file over here. Okay. And I'm going to call this as first service.yaml. Okay. And I'm going to paste the service definition over here. Let me hit save over here. So be sure to save the file. Now, if you switch over to your terminal, you need to run a command. So here we will say kubectl apply -f, and here instead of first pod, we will say first service, like so. And I'll hit enter. Now you will see first service is created and you can get the service using kubectl get service, and you will see that there is this service that exists which is of type cluster IP, and you have this IP here, and this is the port, and the age is it was created 8 seconds ago. So this way you can check for services. Hey there, welcome back. So let us start talking about how you can expose your application. So let us talk about 3 types of services that we have when it comes to Kubernetes. And the type of service determines its accessibility, whether it is from within the cluster, from the node hosting the pod, or from outside the cluster entirely. Okay, so this brings us to the most common types of services, which is cluster IP, node port, and load balancer. So cluster IP is the default type of service. So whenever you don't specify the type, you will get the service of type cluster IP. Now, what does it do is it gives a service its own IP address to communicate with other services within the cluster. And these services are only reachable from within the cluster and they are not exposed outside. Okay. Then you have node port, and node port expands on cluster IP and exposes the service on the same port across each node. Okay. And this makes the service accessible from outside the cluster using node IP, okay, and node port. So this way you can access the service using node port. Now what is load balancer? So load balancer exposes the service externally using the cloud provider's load balancer. So you can think of it that it builds on node port and assigns a fixed external IP to the service. And this is typically used in cloud-based environments where load balancer can be provisioned automatically. Okay. So if you have to see how you can specify the type of the service, you can see this example over here. So here in our example, we did not specify the type. And when we created the service, you can see that we got the service type of cluster IP. But if we specify the type, you will get the type as that of load balancer over here if you run this. Okay, and this is used to expose your application to the outside world because it will give you a fixed IP to your service which can be accessed externally. So this is about types of services and how you can expose your application to the outside world. Hey there, welcome back. So let us start talking about replica sets. So what are replica sets? So replica set is a Kubernetes object that is used for managing and scaling a set of identical pods. Now, why would you need a set of identical pods? So there is a reason for this, and one reason is high availability. So running multiple identical replicas of your application's pod ensures high availability. So if one pod fails or becomes unresponsive, the other replicas can continue serving the application's workload without any interruption, and this redundancy can help maintain the overall availability and reliability of the application. Then you have load balancing. So identical pods enable load balancing across multiple instances of your application. So by distributing incoming requests or traffic evenly among the replicas, you can handle increased load and achieve better performance and scalability. Load balancing also ensures that there is no single pod that becomes overwhelmed with traffic, and it allows for efficient utilization of resources. Then you have scaling. So having identical pods makes it easier to scale your application horizontally, because when the demand for your application increases, you can simply scale up the number of replicas to handle the additional workload. And Kubernetes can automatically distribute the load among the replicas. and this enables your application to handle more traffic without compromising the performance. Then you have something called as rolling updates. So identical pods play a crucial role again during rolling updates or deployments. So when you need to update your application to a new version, Kubernetes follows a rolling update strategy, which involves gradually replacing the old pods with new ones. And having identical pods ensures that the application remains available throughout the update process as new pods are gradually introduced and the old ones are gracefully terminated. Then you have service discovery and load balancing. So identical pods with a common label can easily be discovered and load balanced with or by another Kubernetes resources such as services. Now services can automatically discover and distribute the traffic to all the pods that match a specific label selector. And this provides a seamless and a consistent experience for client accessing your application. Okay. So why do we need replica sets? Okay. So pods are ephemeral in nature, and again, they can be created and destroyed, right? And ephemeral nature makes it challenging to rely on a single pod to provide a particular service. So replica sets mitigate this problem by ensuring a certain number of identical pods are always up and they are always running. And this is really crucial for load balancing and for ensuring the availability of the application. So this is about why we need replica sets. Then what is replica set not? Okay, so a replica set is not designed to handle rolling updates or deployments. Now, replica set only focuses on maintaining the desired number of replicas at any given point of time. So if there is a rolling update or deployment happening, even at that point, replica set will be responsible for making sure that there are some X number of replicas available. And another point is it does not provide declarative updates to the pod it manages. Okay, so to update the pod, you need to create a new replica set with updated configuration and delete the old one. So this is about replica sets. Now, what should you keep in mind about replica sets? So replica sets use a selector to identify the pod it manages. All right, so this is one point, and selector defines the criteria for matching pods. So selector is nothing but a label that is used or a criteria that is used that enables replica set to identify which pod it has to manage. And this is something that we'll see shortly in practicals. So also when creating a replica set, you specify the desired number of replicas that you wish to have at any given point of time. All right, so this is something that you have control on as a developer. Also, if a pod is managed by a replica set gets failed or deleted, the replica set will replace it automatically to maintain the desired replica count. So this is another point. Then you have replica sets are often used with deployments, and deployments are the ones which provide updates, and rolling deployments are defined there, and these are done by managing the replica sets. Then you need to keep in mind that when updating the configuration of pods such as image versions or resource requirements, it is 100% recommended to use deployments instead of directly modifying the replica set, because deployments will make sure that the updates are done properly and are applied to the respective pods. So let us take a look at an example of a replica set. So here I have a notepad file which defines the replica set over here. And you can see over here the API version. I have defined the kind of object that it has, and I've specified replica set over here. Then I have metadata defined over here. So this provides the data that helps you identify the replica set uniquely, like the name of the replica set. Okay. Then you have the spec defined over here. Now spec has multiple labels over here, as you can see. Okay. So here we are talking about replicas. So like I said, that you as a developer has the ability to define how many number of replicas you want at any given point of time for a particular pod. So here I have specified 3 as the count. So at any given point of time, 3 replicas will be made available for this pod over here. Now here I have selector field, and this section is used by ReplicaSet to identify the pods that it should manage. Okay. So for example, here I have specified match labels and app::nginx. So ReplicaSet will manage this particular pod. Okay. And it will make sure that there are 3 replicas always available for this particular label. Then we have template. So this section defines the templates for the pods that ReplicaSet will create. Okay. So metadata under the template defines the metadata for the pods, and it includes the labels that will be assigned for that particular pod. So this is the label that is being assigned. And here you can see this is the label that is being managed. And then you have spec over here, and spec under the template tag defines or describes the state of the desired pods. So in this case, we are specifying that each pod should run a single container using this nginx image, and this is a version of the image. And we are also specifying the container port over here. Okay. So this is the definition of the ReplicaSet file. So I'll just copy this and I'll head over to Visual Studio Code. And here I'm seeing a pop-up which says Docker is installed on my system. Do you want an extension for this? Okay, from Microsoft for Visual Studio Code. So you can just say install if you wish to. So this will just enable you to manage Docker. Okay, so back to this particular thing here. And here I'm going to again create a new file. Okay, so I'll say ReplicaSet. So I'll say replicaset.yaml, something like this. And I'll paste the definition over here. Okay. So I believe the extension is installed now. Okay. So you can see it makes working with Docker easy with all the syntax highlighting and everything, build image and all. So it's good to have this. So yeah, I have created a ReplicaSet over here. And now let us create this. Okay. So let us create this using terminal. So I'll head over to my terminal here. And here what I will say is I'll say kubectl apply -f. And here I'll say replicaset.yaml. Okay. I'll just remove this dot and /. So you have this command here. Now if I say enter, you will see the ReplicaSet is created. So you can now check the pods in the watch mode, and you will see the pods are running. And you can see there are like 3 replicas of this pod here. Okay, because you had specified 3 in the count when defining the ReplicaSet. So here there are 3 ReplicaSets that are like 3 pods from the ReplicaSet that are running over here. Okay, I can just exit the watch mode, and I can even say get pods normally, and you will see the same output. I can even get the ReplicaSet using this particular command. So I can say ReplicaSet here. Okay, you can see desired count is 3, current is 3, and ready 3, and the age is 46 seconds. So this was created just 46 seconds back. Okay. Now let us say I delete a pod, or one pod gets deleted. So how do you delete a pod? So you will say kubectl delete pod, and you will specify the pod name. So let us say we delete this particular pod here. Okay. So I'll copy and I'll paste. Okay. And delete spelling is incorrect, so I'll just make it correct. Okay. So kubectl delete my ReplicaSet. Okay. Now if I run this, the pods gets deleted. And now if you run this in the watch mode, you will see that there is one more pod that was created automatically. Okay. And This was created without you doing anything. And this is replica set in action right now. So you can see how it's managing the replicas. So one pod was deleted and another one was immediately created. All right. So you can see over here, it was within a fraction of a second. So if I keep this open over here, okay, like so. Okay, so let me keep this open here. And what I will do is I will open another instance of PowerShell over here. So let me say, so I'll create one more instance and I'll open this like this in a new window. Or how do I move? So let us now begin talking about the concept of deployments in Kubernetes. So what is a deployment? A deployment in Kubernetes is a high level concept that manages the replica set, and a deployment provides updates for pods and replica sets. So if you take a look at pods and replica sets, they cannot be changed, right? Now you need a way to seamlessly roll out updates and everything during the deployment and development process. Now, how would you do that? So this is where the deployments in Kubernetes come into picture. So what you have to do is you have to only describe the state in the deployment object, and the deployment controller changes the actual state to the desired state at a controlled rate for you. Now, this means that you can seamlessly roll out new features or roll back to previous versions without any interruption because deployments is working for you. So let me show this to you. So we are going to create a new file and I'm going to call this as first deployment.yaml, like so. Okay. Now here I'm going to have a notepad being added here. So you can see I have this notepad over here where I have written the definition of my deployment file. Okay. So here you can see I have the API version defined, then the kind of the object that I'm creating, which is deployment. I'm specifying the name over here. So metadata helps you uniquely identify a particular object. And here I'm saying my deployment is the name of this object. Then I have spec created over here. Okay, now spec defines the desired state of the object. So this includes the number of replicas, the selector, and the template over here. Okay. Now replicas specify the number of replicas that you want to run for a particular pod. And in selectors, you specify which pods you want deployment to manage. Okay. So in this case, the selector is looking for the pods label app my app. Okay, you can see this is the label over here. Okay, then you have template. Then this template is used for creating new pods. Okay, and this template includes the pod specification or spec, which includes things like pod containers, the names of those containers, and the images the containers should run. So this is all the definition that we have. Okay, so what we are going to do is we are going to move this to our Visual Studio Code over here. Okay, in the first deployment.yaml file. Now, as you can see, you have created the deployment object over here. Now, why do you need deployment objects? So number one use case or the reason you have is automated rollouts and rollbacks. So deployments are designed to facilitate updates to your application in a controlled manner. Now, when you update your application version or configuration, Kubernetes will replace or it will gradually replace the old instances with the new ones, ensuring there is no downtime during the transition. And if something goes wrong, Kubernetes can also roll back the changes. So this is a benefit. So this is about automated rollbacks and rollouts. Then you have scaling. So deployments also allow you to scale up or scale down to match the demand. Okay. And then you have health monitoring. So Kubernetes continuously monitors your health of the pods in deployments and restarts any pods that fails. It ensures self-healing of your application. Okay. So we have created a deployment file Okay, now let us head over to the terminal. Okay, and I'm going to just minimize this one. Okay, and here I'm going to just create that particular deployment. So I'll say first deployment dot YAML. Okay, sorry. So I got an error. It says no objects, and the reason is I have not saved the file. Okay, so you need to make sure you save the file, and then here you need to run this command. So you will see the deployment is created over here. Now you can say kubectl get deployments to get the deployments that have been created, and you can see the status over here. Okay, so this command will give you the deployments, and you can even get the pods over here. So I can say get pods like so, and you can see image pull back off. So you can see there are quite a few pods that are up. So let me run this in the watch mode. Okay, so you can see there are quite a few pods that are running in. Okay, and there is, I believe, some error that is coming in this image. Okay, but this way you can see the deployments going on, and you can even take a look at the pods that have been created by the deployment. Now you also have describe command, which enables you to see the event related to your deployments, including any errors, warnings, or anything. Okay, so you can say kubectl describe deployment, and you can add the deployment name over here. So the deployment is my deployment over here. Okay, so I can say something like this. Now you can see all the events over here. Okay, so you can see 3 desired, 3 updated, and 3 total. 0 are available and 3 are unavailable. Okay, now if you see over here, so you can see all the logs over here as to what happened. Okay, so you can just go through this if you wish to, and if you wish to describe your deployment. So you can even check the logs for your pods. So I can say get pods, and you can say kubectl logs, and you can add the log, like the pod name over here, like so. And you will get the logs for that particular pod. So this pod does not have any logs. Is that so? So yeah, I believe there is nothing for this particular pod, but let me check for these pods. So you can see over here, container my app in is waiting to start and failing to pull image. So there is this error that we are seeing. Okay, and wait a minute. So my app. So there is no container called my app over here, is what I can see. Okay, so it's failing to pull the image, and that is why it's failing over here. So here, like image, so this image does not exist. Okay, so we need to add a valid image over here. And if we do that, so let me add this image here, and let me apply this. Okay, so if I save this, and if I go over here, and if I say apply the deployment, and if you go in watch mode, you will see, okay, so this pod is being terminated, the deployment is being terminated. So let me check the status. So I'll just run pods over here, and you can see it's started now. Okay, because we have specified a valid image name here. Okay, so it terminated everything and it started the required pod over here. Okay, so yeah, so this is deployments in action. Okay, you can even use describe to describe your deployments. Now, how would you manage changes in pods with the deployments? So to update the pod and add more containers, the recommended approach in Kubernetes is to use a high level resource called deployment. Okay, now this is because deployment manages the life cycle of the pods. Okay, so a typical workflow to update the pod and add more containers using a deployment would be to have a deployment file. Okay, and in the deployment specification, you can specify the number of replicas. So let's say if you want to make any updates, you can update the changes over here. Okay, and if you want to add any containers, you can add more containers over here. And then you go back and apply the deployment, and the changes would be applied. And this is similar to the change that we just did over here. So we just updated the image name over here, and you could see those changes applied. Okay, so make any changes over here and apply, and those changes will be reflected in your application. So this is about deployments and how you can work with them.